Hello friends, welcome to Neet World. Myself Abhilash, Mathematics faculty for MSET, KSET and JEE. So till now we learned the concepts of trigonometry. So today we will be learning the concepts of inverse trigonometry. So what do you mean by inverse trigonometry? So one thing I can say is, if you are considering theta as trigonometry, that means if you are looking at theta like this, inverse means we will be looking at theta just like this. That is the meaning of inverse trigonometry. You can say a mirror image of trigonometry is inverse trigonometry, which you will understand right now. Got it? Now let us understand what do you mean by inverse trigonometric functions. Okay, so in the sets, relation and function chapter you would have learnt about what is an invertible function. Okay, invertible function is one which is both 1 1 and onto, right? Which is both 1 1 and onto. So similarly, a function to be an inverse trigonometric function, that means it should be invertible, right? So a function to be inverse, it should be first invertible. So a function is invertible if it is 1 1 and onto, that is it should be a bijective function, right? You have learnt in sets, relation and functions chapter, for a function to be invertible it should be both 1 1 and onto. Like that, let us consider a function as x tends to y be an invertible function. That is, be an invertible function means what? It should be both 1 1 and onto. So this f inverse will exist, that is inverse of f will exist, that is function f of x, that is it becomes inverse function f inverse of x, f inverse of x or f inverse, just f inverse. Since we have taken here only f, this inverse function will be f inverse. For f we add the function as x tends to y, so x tends to y, f inverse will be y tends to x. Got it? So suppose a function is saying you are moving from a to b, okay, you are moving from a to b, that is just a normal function. Inverse function is the one which says that you are moving from b to a, that is reverse. Got it? That is the meaning of inverse. Got it, friends? So here f as x tends to y is just a function. If it is an invertible function, this f inverse will exist. F inverse is given by y tends to x with the property f of x is equal to y. This is what? Just a normal function. For this inverse is f inverse of y. So f inverse of y is equal to x. F inverse of y is equal to x. This is the meaning of invertible function. This is the meaning of inverse trigonometric function. Is it clear? Next, this is the definition of inverse trigonometric function. So while learning about trigonometry, we learned the graphs of what? Sin x, cos x, tan x and other inverse ratios, that is cosec x, secant x and also cot x. Now let us have a look at this, how the graph changes between trigonometric function and its inverse trigonometric function. How the graph changes between sin x and its inverse is called sin inverse of x. For cos x and its inverse is called cos inverse of x, and tan x and its inverse is called tan inverse of x accordingly. So let us have a look at this, friends. See here, this one is what? This one is denoting both. This is trigonometric function, y is equal to sin x. This is a trigonometric function. For this, the graph is, you can see the blue line. This blue line is representing what? Trigonometric function. This blue line is representing trigonometric function. And this red line, this red curve is representing what? Is representing inverse trigonometric function. I can represent it as ITF. Okay, that is inverse trigonometric function. Okay, now you can observe this. You can observe this. This line is nothing but is representing a straight line where it is y is equal to x. This is a straight line. Along this straight line, if you see how the inverse function and normal function, that is y is equal to sin x, how they have aligned. How they have aligned? It is like this. See here, it is like this. It is aligned like this. It is aligned like this. This is trigonometric function. This is what, friends? This is inverse trigonometric function. Inverse trigonometric function. So what I can say, when you take trigonometric function and inverse trigonometric functions, they are nothing but what? They are mirror image. They are nothing but mirror image of each other. Okay, what do you mean by mirror image? Mirror image. Some people might have doubt regarding what is a mirror image. So suppose, friends, if you stand in front of a mirror, your image itself will be visible. So what is right becomes left. What is right will become left. Correct na? So see here, friends. So see here. Suppose I draw a figure here. Okay. Draw a figure here. Suppose I write h here. Suppose I write h here. Suppose consider this as a mirror. Consider this as a mirror. So this mirror image, what we get here will be same thing, but h will come here itself. Okay. So what is left will become right. That's it. Nothing changes. Okay, water image means what is top will become bottom. What is bottom will become top. But here we are talking about mirror image. When you consider trigonometric and inverse trigonometric, what is the change? Mirror image. Okay. So what is right will become left. What is left will become right. So what will happen here? There will be flipping of domain and range. There will be flipping of domain and range. So how it will become? We will see. Okay. So this is about when we talk about sin x graph. Y is equal to sin x. Its inverse is y is equal to sin inverse of x. Okay. So they are mirror image of each other. What about cos x? I am telling for all the trigonometric functions, you are having mirror image as inverse trigonometric function. So even for cos x, it is the same. It's not going to change. So see here, friends. So for cos x, this is the line. This blue line is representing y is equal to cos x. So what about inverse? So it is going like this. It will go like this. So it is going right means it is going left. Correct now? So this is inverse function. This is inverse trigonometric function for cos x. This is the graph of cos inverse of x. Y is equal to cos inverse of x. This is going like this. This is going to the right. Okay, towards right. This is going towards left. Okay, this is the meaning of inverse trigonometric function when it comes to cos x. What about tan x? What about tan x? See here also y is equal to x. Along y is equal to x line, they are splitting into two curves which are mirror image of each other. What about tan x? Let us see. What about tan x? Let us see. So see here, friends. See here, friends. This blue line. This blue line is representing y is equal to tan x. This is what? Trigonometric function. Y is equal to tan x is what? It is a trigonometric function. So what about y is equal to tan inverse of x? We know that it is an inverse trigonometric function. It is inverse trigonometric function. So this is y is equal to x line. Along this straight line, we are having mirror image. This mirror image is here. The mirror image of this is this one. Okay, that is the meaning of inverse trigonometric function. Y is equal to tan inverse of x. This is the graph for y is equal to tan inverse of x. So right now we learn what is the definition of inverse trigonometric function and also the graphs of inverse trigonometric function. Now proceeding further, see here. Proceeding further, they are asking what is the domain. Before that, let us have a look at something. So in inverse trigonometric function, you must know one thing. So trigonometric function, this is trigonometric function, this is inverse trigonometric function. Okay, inverse trigonometric function. See here, for trigonometric function, we had something called domain and range. Domain and range. So what will happen here? I told you what is left will become right. What is left will become right. So here it will become RD. Here it will become RD. That means what? What is the domain here? What is the domain here? That will become range. In inverse trigonometry, what is the domain? That will become range. What is the range here? That will become domain. What is the range here? That will become domain. What is the range here? That will become domain. Okay, that will become domain when we consider trigonometric function and inverse trigonometric function. So there is flipping, that is flipping of domain and range. Domain and range with respect to trigonometric function and inverse trigonometric function. Okay, there is flipping of domain and range with respect to trigonometric and inverse trigonometric function. Suppose sin x, its range is -1 to +1 within closed bracket, that is closed interval. That is the range of sin x. What about sin inverse of x? Sin inverse of x range of sin x is -1 to +1. That will become the domain of sin inverse of x. Okay, for sin x range is -1 to +1. Okay, both are included. That is range of sin x. When it comes to sin inverse of x, the same value -1 to +1, that will not become the range, that will become the domain. Got it? So look at this. That is what the this table is showing. So y is equal to sin inverse of x. Y is equal to sin inverse of x. I told earlier it was range in trigonometric function. This is becoming domain. Okay, this is domain. This is domain here. This is the range. Okay, -π/2 to +π/2. Both are included. Principal value branches. Okay. Now this is 0, pi. 0, pi for cos inverse of x. Then cosec inverse of x, it is -π/2 to +π/2. So one thing you must understand here. This one, y is equal to sin inverse of x, y is equal to cosec inverse of x, y is equal to tan inverse of x will behave similarly, will behave in the same way. Okay, they are both, three are related, sin inverse of x, cosec inverse of x and tan inverse of x with respect to domain and range. they are similar. They are similar in the sense they are not same. I am telling they behave similarly. They behave similarly. Okay. But when you consider cos inverse of x, secant inverse of x, and cot inverse of x, they behave similar. Okay. This is called Trimurti trick. Which trick? This is called Trimurti trick. That I will explain further. This is about domain and range. Now, look at this. Look at this. But before going to that, let me explain the Trimurti trick. Just a minute. How they behave similarly, I will show you right now. Let me draw a coordinate axis, x and y axis. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant, this is pi by 2, okay, this is minus pi by 2, this is 0, this is 2 pi, this is 2 pi, and this is what? This is pi. This is pi, right? Now, I will talk about the Trimurti trick. Okay, let me write it as Trimurti trick. Trimurti trick. I told what? Sine inverse of x and cosec inverse of x and tan inverse of x behave similarly. Why? I will show you now. So, if I write, see here, if I write here, just have a look at it. If I write here, sine inverse of x, its range is what? Let us consider range. I am talking only with respect to range. Its range is what? It is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2 is this close bracket, that is both are included. So that is, its range is this one. When I talk about sine inverse of x, it will be in this range. The principal value branch will be in first quadrant and fourth quadrant. Got it? So it is for sine inverse of x. Okay. It is having minus pi by 2 to plus pi by 2. Okay. Next thing, when I talk about cosec inverse of x. Okay. Before talking about cosec inverse of x, let me talk about tan inverse of x. Let me talk about tan inverse of x, friends. So tan inverse of x, it is also minus pi by 2 to plus pi by 2. Okay. It is also minus pi by 2 to plus pi by 2. Now we have to focus very much. Okay. Focus very much here, because here this is closed interval. This is what? Open interval. This is open interval. Why? Why is my question. Because tan inverse of x at endpoints will give you undefined value. Okay. So you have to exclude the endpoints. This is also minus pi by 2 to plus pi by 2. Here both are included. That is minus pi by 2 and plus pi by 2 are included. But here minus pi by 2 and plus pi by 2 are excluded. Between values you have to take. Why? See, suppose I take tan inverse of x. Okay, tan inverse of x, where x is equal to pi by 2. Oh, okay. So tan inverse of pi by 2 is what? Tan inverse of pi by 2 is what? Tan inverse of pi by 2 is what? Suppose I take tan pi by 2. Okay, tan pi by 2 is what? Sin pi by 2 divided by what? Cos pi by 2. Correct now? Tan pi by 2 is sin pi by 2 by cos pi by 2. Cos pi by 2 is what? Cos 90 is 0. So this will become what? This will become not defined. This will become not defined. Okay, not defined. Okay, that is why for tan inverse of x, pi by 2 we should not include. Similarly, we should not include minus pi by 2. This is what you have to understand. Now let us look at cosec inverse of x. Cosec inverse of x, this is one thing. This is another thing. So let us look at cosec inverse of x. Okay, cosec inverse of x, its range is minus pi by 2 comma plus pi by 2, both are included, that is within the closed bracket, minus only one angle we have to remove, that is angle 0. You should not be having angle 0. This complete except 0 angle. Why is my question. See here, cosec x is nothing but what? Cosec x is nothing but 1 by sin x. 1 by sin x. Okay, if we take x is equal to 0, what will happen? It will become 1 by sin 0. Okay, 1 by sin 0 is what? 1 by 0, this will become not defined. Okay, this will become not defined. That's why you should eliminate 0. So sin inverse of x, cosec inverse of x is having the same range, but when it comes to cosec inverse of x, you have to remove 0. Okay, you have to remove 0. You have to exclude 0. Okay, both are closed bracket only. That is closed interval. Next, when it comes to tan inverse of x, it is similar to sin inverse of x, but it is open bracket. Pi by 2 and minus pi by 2 are not included. Got it? So it is the principal value branches of sin inverse of x, cosec inverse of x and tan inverse of x is what? It is lying in first quadrant and fourth quadrant. This is the most important thing which you have to remember. Got it, friends? Next Trimurti trick for, I told you, Trimurti trick for you understood for sin inverse of x, cosec inverse of x and also tan inverse of x. Now what about cot inverse of x, cos inverse of x and also secant inverse of x? Let us have a look at it. Okay, see here, friends. Cos inverse of x, cos inverse of x. What is the range for this? What is the range of cos inverse of x? It is 0 comma pi. It is 0 comma pi. Okay, 0 comma pi. Okay, what about secant inverse of x? Secant inverse of x, it is also secant inverse of x. This is also 0 comma pi. Let me write it here. Have a look at it. This is also 0 comma pi. Secant inverse of x. This is also 0 comma pi. Okay. Just think what I have to remove. You have to think what I have to remove. What about cot inverse of x? Cot inverse of x. Cot inverse of x is 0 comma pi, but this is open interval. This is open interval. This is open interval. Why? I'll tell you. Suppose I write cot x I write it as cos x by sin x. Cos x by sin x. If I write sin pi, what will happen? What if I write sin pi? If I include sin pi, what will happen? Sin pi is 0. Sin pi is 0. So this will become undefined. This will become not defined. This will become not defined. Not defined at pi. Not defined at pi. That is why we are taking 0 comma pi, but both are not included. That is, both are not included, but this is open interval. Suppose I take sin 0, this will become sin 0 will become 0. So this will again become not defined at 0. That's why you have to take open interval, not closed interval. That means 0 and pi are not included, only the between values are included. Okay, so this Trimurti trick is what? They are flipping like this. See here, they are flipping like this. You can take the principal value branches for these three: cos inverse of x, secant inverse of x and cot inverse of x is ranging from first quadrant to second quadrant. Okay, secant inverse of x, I told it is closed interval 0 comma pi. Here also cos inverse of x is 0 comma pi, but I have to remove one value. What is that value? Think about it. What is that value? That value is nothing but pi by 2. I have to remove pi by 2. Why pi by 2? Why pi by 2? So secant x is nothing but 1 by cos x. So 1 by cos x at x is equal to pi by 2 is 0. 1 by cos x at x is equal to pi by 2 is 0. So it will become 1 by 0. So 1 by 0 means it will become not defined. So that's why I have to remove pi by 2. That's why I have to remove pi by 2. I hope now it is clear to you, the Trimurti trick. Okay, these are the principal value branches for sin inverse of x and cos inverse of x, cosec inverse of x and tan inverse of x. It is ranging from minus pi by 2 to plus pi by 2. You know the exact ranges and the quadrants, first quadrant and fourth quadrant. Okay, that is first quadrant and fourth quadrant. Okay, first quadrant and fourth quadrant. And when we talk about this thing, cos inverse of x, secant inverse of x and cot inverse of x, it is flipping like this, 0 to pi like this. It is flipping horizontally. This is flipping what? This is flipping vertically. This you have to remember. Got it, friends? Now let us look at some basic questions. Okay, let us have a look at some basic questions here. Just a minute. So you should understand that trigonometric functions and inverse trigonometric functions are mirror image of each other. That is the most important thing you have to remember. That will help us solve a lot of questions. Just a minute. Okay, so we were here. So I explained about graph. So first we learned definition of inverse trigonometric function. Next we learned the graphs of inverse trigonometric function. Then we learned about domain and range. Domain and range, that is domain will become range and range will become domain when it compare trigonometric function and inverse trigonometric function. And also we learned the Trimurti trick. Now based on that we'll solve certain questions, certain basic questions, so that your concepts becomes clear. Okay, based on this concept only we will do the questions. Okay, now before that, see here some properties we have to learn. So sine inverse of sine theta is theta. Okay, sine inverse of sine theta is theta. Similarly, cos inverse of cos theta is theta. Tan inverse of tan theta is theta. Secant inverse of secant theta is theta. Cot inverse of cot theta is theta. Okay, so what is this? What is all this? What is all this? What is this? These are all what? This I can simply write it as where theta belongs to range. These not real numbers, where theta belongs to range. These are all the range of these functions. Got it? So theta belongs to range. Okay, next thing, see here, look at this. Okay, this is another property where you are finding not theta but the actual value. Suppose you are writing sine theta is equal to some value. Okay, sine 30 is 1 by 2 or sine pi by 6, particularly in radians. Sine pi by 6 is 1 by 2. There pi by 6 is what? The pi by 6 is range, and 1 by 2 is what? We call it as domain here when it comes to inverse trigonometry. So that 1 by 2 value is nothing but x here. Okay, so sine of sine inverse of x is x. Cos of cos inverse of x is equal to x. Okay, tan of tan inverse of x is equal to x. Accordingly for other functions also. Okay, for other functions also. What about these things? This I can generally write as, or I can generalize and write it as x belongs to domain. There we wrote theta belongs to range. Here x belongs to domain. Got it, friends? This is very simple. These are the two properties which are very important. We have to remember. Next thing, friends. Let us see the questions. So they are asking the principal value of sine inverse of sine 2 pi by 3. We know that sine inverse of sine theta is theta. We can write directly 2 pi by 3. Is it correct? No. Why? Because 2 pi by 3 is given. 2 pi by 3 means what? It is 120 degree. But what we learned? Sine inverse of x. The range is what? Sine inverse of range for sine inverse of x. Range for sine inverse of x is what? Sine inverse of x. The range is what? Let me write it as theta. Let it be x only. For it, the range is minus pi by 2, comma pi by 2. But this 2 pi by 3, is nothing but 120 degree. This is outside this range. So I have to bring it within the range. So what I can do, this 120 degree, to make it within the range, what I can do, I can subtract from 180. So this will become what? I can write it as sine 2 pi by 3. I can write it as sine inverse of, this will become sine inverse of sine 2 pi by 3. I can write it as pi minus pi by 3. That is what? 180 minus 60 is what? 180 minus 60 is 120. But we know that sine pi minus pi by 3 is pi by 3. Sine 180 minus theta is sine theta. So this will be sine inverse of sine pi by 3. So sine inverse of sine theta, this is definitely within the range. That is pi by 3 is 60 degree. 60 degrees lies between minus 90 and plus 90. Definitely it is within our range. That is not our range, that is the range of sine x. So the correct answer is pi by 3. That is, answer to this question is pi by 3, which is in option, which is in none of the above. Okay, that is none of this, because the answer is pi by 3. Next one, they are asking value of cos inverse of cos pi by 3 plus sin inverse of sin pi by 3. First of all, let me write down for sin inverse of x, what is the range? The range is minus pi by 2, comma pi by 2. Minus pi by 2, comma pi by 2. What about cos inverse of x? Cos inverse of x, the range is 0, comma pi. The range is what, friends? 0, comma pi. We learned. Okay, that is, this will flip vertically, this will flip horizontally, we learned. Okay, so what about 5 pi by 3? 5 pi by 3 is nothing but what? Pi by 3 is, pi by 3 is what? Pi by 3 is 60, 60 into 5 is 300. This is 300, this is also 300. So both are outside the range. This 300 is outside the range of sin inverse of x, and cos inverse of x also, for it 300 is outside the range. So both of them we have to bring it within the range. So for cos we have to bring it within the range of 0 comma pi, and for sin we have to bring it within the range of minus pi by 2 to pi by 2. So let us see what can be done. So cos inverse of cos 5 pi by 3. Cos 5 pi by 3, I can write it as what? I can write it as pi minus, what I can write? Instead of pi, I can take it as 2 pi. I can take it as 2 pi. So cos 2 pi minus, okay, 360 minus 60. 360 minus 60 is 300. So 2 pi minus pi by 3. Cos 2 pi minus pi by 3 is, I got it this one. Okay, 2 pi minus pi by 3. Next, this one. Sin inverse of 300 is there. 300 is there. So this is what? This can be written as sin inverse of 300 is there, no? What I can write? I can write it as 2 pi minus pi by 3. This will be sin inverse of 2 pi minus pi by 3. Sin inverse of 2 pi minus pi by 3. Okay, sin inverse of 2 pi minus pi by 3. So what do we get here? Cos of 2 pi minus theta. Cos of 2 pi minus theta is cos theta. Okay, let me write it here. Cos of 2 pi minus theta is cos theta, because it is fourth quadrant, cos is positive. But when it comes to sine, fourth quadrant, sine is negative. Sine of 2 pi minus theta is minus sine theta. So this value will be equal to what? Cos inverse of cos pi by 3. Okay, so this value will be sine inverse of minus sine pi by 3. Minus sine pi by 3. Got it? Sine inverse of minus sine pi by 3, or I can write it as minus pi by 3. Or I can write it as minus pi by 3 only. Okay, minus sine theta is nothing but minus, I'll send it inside, it will become minus pi by 3. So what I'll get? Cos inverse of cos theta is theta, plus sin inverse of sin theta is theta, but here theta is negative, so I have to take the negative value, minus pi by 3 only. So this is what? This value will be equal to 0. This I'll explain right now. Okay, negative of inverse trigonometric functions. What do we call negative of inverse trigonometric functions? How do we get the negative of inverse trigonometric function? What are those properties? I'll tell you right now. But answer to this question, pi by 3 minus pi by 3. How it become minus pi by 3? I'll explain right now. Pi by 3 minus pi by 3 is 0. The answer to this question is 0. Now let us learn negative of inverse trigonometric functions for your understanding. See, look at this. If we are going to that question, let us see negative of inverse trigonometric functions. See here friends, I told you three trick. Be it range, domain, graph, whatever. I told you, what did I tell you? Sin inverse of x, cosec inverse of x, and tan inverse of x behave similarly. Okay, they can be grouped into one. And another group is what? Cos inverse of x, secant inverse of x, and cot inverse of x. So they behave similarly. Okay, now see, sin inverse of x minus x is minus sin inverse of x. This minus will be pushed outside. This tan inverse of x will be minus will be pushed outside, tan inverse of minus x. When we talk about cosec inverse of x, this minus cosec inverse of minus x, this minus will be pushed outside. So these three are similar. When you talk about cos inverse of minus x, cot inverse of minus x, secant inverse of minus x, it is not just minus cos inverse of x, it is pi minus. Here also it is pi minus. Here also it is pi minus. So here only minus is coming outside. Here pi minus is coming outside. Why? We will understand now. Okay, this derivation is there in your intermediate, but let us see. I will explain again so that you understand how it is happening. So suppose, let me take it as sin inverse of minus x, let me take it as theta. Okay, let me take it as theta. So this will become what? This will become what? This will become minus x is equal to sin theta. minus x is equal to sin theta. This I can write as x is equal to minus sin theta. X is equal to minus sin theta. Correct na? X is equal to minus sin theta. So x is equal to this minus sin theta. We know the properties of trigonometry. Okay. Sin of minus theta is minus sin theta. So similarly this minus I can send it inside. So this will become sin of minus theta. So this implies what? This implies sin inverse of x. Sin inverse of x is equal to minus theta. Sin inverse of x is equal to minus theta. So this minus I can send it this side. So this will become what, friends? Minus sin inverse of x. Minus sin inverse of x is equal to minus sin inverse of x is equal to theta. Minus sin inverse of x is equal to theta. But what is theta? What is theta? Theta is this one. Theta is sin inverse of minus x. So this becomes minus sin inverse of x is equal to sin inverse of minus x. This you need not know how it comes, but I am explaining how this formula has come, how this property has come. Sin inverse of minus x is equal to minus sin inverse of x. This is how it comes. Okay, understood? This is with respect to our trigonometry trick, sin inverse of x, tan inverse of x, cosec inverse of minus x. Actually, it is how minus is coming outside. Here now let us understand how pi is coming outside. Pi minus is coming outside. Okay, how pi minus is coming outside, let us understand now. So see here, friends, let me write it here. Okay, this is with respect to sin inverse. Let me write cos inverse of minus x is equal to theta. Cos inverse of minus x is equal to theta. So I can write it as cos inverse of minus x is equal to theta. So this becomes theta is equal to, or I can write it as minus x is equal to cos theta. Minus x is equal to cos theta. Now if I send x is equal to minus cos theta, if I send minus theta inside, okay, if I send minus inside, okay, it will become just positive of cos theta. But if I have to get minus cos theta, it should be written as cos of pi minus theta, because cos of pi minus theta is minus cos theta. So this will be equal to what? Cos of pi minus theta. Okay, cos of pi minus theta. So this implies x is equal to cos of pi minus theta. Cos of pi minus theta. Got it? Cos of pi minus theta. Now pi minus theta I can write it as cos inverse of x. So cos inverse of x is equal to pi minus theta. Cos inverse of x is equal to pi minus theta. But theta is what? Cos inverse of minus x. Cos inverse of minus x I can write it as pi minus theta. So this will become, this I can write it here, cos inverse of x. This theta I can send it inside, and cos inverse of x I can send it that side. Okay, here theta I can send it to the LHS, and cos inverse of x I can send it that side. So it will become what? It will become theta is equal to pi minus cos inverse of x. Theta is equal to pi minus cos inverse of x. So theta is what? Cos inverse of minus x. So theta is equal to cos inverse of minus x. So what will happen? Cos inverse of minus x will be equal to pi minus cos inverse of x. This is what we get. Okay, I have just shown you how this value comes. Clear, friends? I have just shown you how this value comes. Okay, this is the negative of inverse trigonometric functions. So when it comes to sin inverse, tan inverse and cosec inverse, minus will come outside. When it comes to cos inverse, secant inverse and what? Cot inverse, only pi minus comes outside. Pi minus the inverse values, inverse trigonometric functions. Got it? Next question. Having understood what is the negative of inverse trigonometric function, let us look at this question. Let us have a look at this question, friends. They have given sin inverse of 2 pi by 3. Okay, sin inverse, we know that it should be minus pi by 2 to plus pi by 2. The range, let me write it here only for our understanding. Cos inverse is 0 comma pi. 0 comma pi. What about tan inverse? Tan inverse is open bracket 0 comma open bracket, it is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. This is the range of tan inverse of x. Okay. Here we are having 2 pi by 3. 2 pi by 3 means 120. But I want within pi by 2 and minus pi by 2. So this will become sin of pi minus pi by 3. So this will become what? Sin inverse of, I will write it, sin inverse of pi minus pi by 3. Okay, got it? Next, cos inverse of 7 pi by 6. Cos of 7 pi by 6. 7 pi by 6 is what, friends? 7 pi by 6 is nothing but 210 degree. 210 degree, I can make it as 180 plus 30. 180 plus 30, but that is not required. That is going out of the range. It is going above pi. So to bring it within pi, what I can do? I can write it as 2 pi minus. I can write it as 2 pi minus. Let us see. Cos inverse of 2 pi minus 5 pi by 6. 6 2s are 12. 12 minus 5 is 7. 7 pi by 6 we will get. Cos of 2 pi minus 5 pi by 6. Okay. This will be fine. Next, tan inverse of tan 3 pi by 4. Tan inverse of tan 3 pi by 4. What I can write? Tan inverse of tan 3 pi by 4. I can write it as what? Tan inverse of tan 3 pi by 4. That is 135 degree. I can write it as tan inverse of tan pi minus pi by 4. Tan inverse of tan pi minus pi by 4. Tan inverse of tan pi minus pi by 4. Now let us have a look at this. Sin pi minus pi by 3 is sin inverse of, this will be sin inverse of sin pi minus pi by 3 sin pi by 3. Got it? Sin pi by 3 plus cos inverse of cos 2 pi minus pi by 5 by 6 is cos 5 pi by 6. Cos inverse of cos 5 pi by 6. Okay. Now plus tan inverse of tan pi minus pi by 4. Tan of 180 minus theta, because tan of 180 minus theta is coming in second quadrant. In second quadrant tan is negative. So this will become tan inverse of what it is? Tan of minus pi by 4. Tan of minus pi by 4. Got it? Tan of minus pi by 4. So this will be sin inverse of sin theta is pi by 3 plus cos inverse of cos theta is 5 pi by 6. Okay, 5 pi by 6 minus pi by 4. So what is the LCM, friends? What is the LCM? LCM is 12. 12 is the LCM. 4 pi plus 2 pi. Okay, 4 pi plus 2 pi. What is this? 4 pi plus 2 pi. Okay, 2 5s are 10. This is 2 5s are 10. This is 2 5s are 10. This is 10 pi minus 4 3s are 3 pi. Okay, this is 3 pi. So you will get it as 14 pi minus 3 pi, that is 11 pi by 12. This is the answer, friends. The answer to this question is 11 pi by 12. Okay, so you must be careful while knowing the range of sine, cos inverse and tan inverse. Okay, tan pi minus pi by 4, that is minus pi by 4, because tan in second quadrant is negative. Remember this. This here 2 pi minus pi by 6 is, it is fourth quadrant. In fourth quadrant cos is positive. Okay, ASTC rule. Okay, and in second quadrant sine is positive. Okay, pi minus pi by 3 is second quadrant. 180 minus 60. 120 can be written as 180 minus 60. Sine 120 is second quadrant, sine is positive. Got it? Next question. Let us have a look at next question. The principal value of tan inverse of cot 43 pi by 4. Okay, so some people what they will do is they will try to convert cot in terms of tan, and then try to solve this question. This was asked in JEE Mains 2014. Okay, this is which question which we solved? This was JEE Mains 2022. Very simple question. Okay, next question. See here, the principal value of tan inverse of cot 43 pi by 4. Cot 43 pi by 4. So let us take first cot 43 pi by 4. 43 pi by 4. Okay, 43 pi by 4. What I can see is I can write it as cot 40 pi plus pi by 4. Cot 40 pi plus pi by 4. Or I can write as not 40. Or I can write as cot 10 pi plus pi by 4. Cot 10 pi plus pi by 4. Let me see. So this can be written as cot 10 pi plus 3 pi by 4. Cot 10 pi plus 3 pi by 4. Cot 10 pi plus 3 pi by 4. If you take LCM, this will be 40 pi plus 3, 43 pi by 4 divided by 4. So cot 10 pi plus pi by 4. Okay, cot 180 plus theta. cot 180 plus theta, then you don't worry. So pi plus theta is coming in third quadrant. 3 pi by 4 is coming in third quadrant. In third quadrant what happens? Third quadrant what happens? Just let us write down. See here, this will become cot 10 pi plus 3 by 4. It will remain cot 3 pi by 4. It will remain 3 pi by 4. Now look at this value. This value is positive. Now look at this value. Cot 3 pi by 4. Cot 3 pi by 4 is what? It is coming in second quadrant. In second quadrant, only sine and cosec are positive. What about cot? Cot is negative. So this value 3 pi by 4, the value is 1. Okay, the pi by 4, the value is 1. Since it is 3 pi by 4, this will be equal to minus 1. This will be equal to minus 1. You have to remember this. Okay, pi by 4 is positive, 3 pi by 4 is negative, 5 pi by 4 is positive 1, 7 pi by 4 it is negative 1. You have to remember this. Okay, this is minus 1. So this value will become what? Tan inverse of minus 1. Tan inverse of minus 1 is minus tan inverse of 1 as per the property of, that is negative of inverse trigonometric functions, which we learn. Tan inverse of minus x is minus tan inverse of x. So minus tan inverse of 1. Tan inverse of 1 is what? Pi by 4. Okay, minus pi by 4. What is the answer? That is option B. Okay, that is option B. This is minus pi by 4. Alright friends, I'll wind up now. Okay, let's continue with inverse trigonometry in the next session, where we'll conclude with inverse trigonometry, and in the upcoming session we will do JEE Mains 2024 and 2025 PYQs. When it comes to 2025, we'll be doing only the session 1. Since only session 1 is done, that is January session, we'll be doing, and 2024 both January and April sessions PYQs of both trigonometry and inverse trigonometry. Got it friends? Thank you so much. Stay tuned. Please subscribe to our channel, like and share. Take care.